Good day, everyone. Nice to meet you. My name is Alex. Anatoly and myself, we both co-founders of PRIZ Guru. And today we're going to present a webinar about engineering thinking, the missing piece in modern education. But first of all, I want to express my appreciation for our friends from Edutechnia, and specifically to Romano, to allowing us to present this webinar. And hopefully we have more collaborations in the future. So, engineering thinking. Again, we want to concentrate what is the missing piece in our modern education and why is it important. As usual, we starting with a quote. And today's quote is from Socrates that says, "I cannot teach anybody anything. I can only make them think." And we'll talk about this in this webinar. So the agenda for today is we're going to go do a little bit of introduction about PRIZ and about ourselves. We'll talk about what is engineering in general and who are engineers. What's going on with the current education systems today, how they train engineers, what is missing and what's the cost of that gap. Then we'll dive into problem solving with engineering thinking approach. And we'll go through a couple of examples, and then we want to present the ecosystem of PRIZ as a whole. And what does it give us? What does it allow us to do? And we'll touch a little bit about AI, since it's a very trending word today. So, excuse me. So, PRIZ Guru, we are a platform that built to help people to solve problems and work on innovation projects. As I mentioned, we both co-founders, Anatoly Agulyansky and Alex Agulyansky himself. As you can imagine, we are a family. And I'll let Anatoly to introduce himself.
Hi, I'm Anatoly. I'm a doctor of chemistry. I've been working a long time in academy and in industry. And what I learned, which is very important, that I learned what does it mean good engineer. A good engineer in today's situation is a problem solver. So if you wanna succeed in doesn't matter in academy or in industry, please learn how to solve problems. We're getting into the world of problem solving. Thank you.
Again, my name is Alex. I like to think about Anatoly as the brains behind the operation. I'm more just executing and building, helping to build the product itself. I have quite some years in R&D and product development and software world and SaaS products and mostly in startups, where again, problem solving is extremely important, and especially when you competitive startup world, it's important to understand how it impacts your growth as a startup or even a mid-sized company, and definitely a large company is not exception. So let's start. First of all, we want to answer the question of what is engineering, and many times we going and digging out some definitions from dictionaries, and these are the three examples that we kind of wanted to focus on. First is engineering is a discipline dedicated to problem solving. Great. Another one that we found, an engineer is a person who uses scientific knowledge to solve problems. And the third, engineers are groundbreakers, finding solutions to complex problems across a range of industries. So as you can see, all three of these, and there's probably much more definitions that we can find, they all concentrating on engineers and problem solving. Anywhere you look, it's always engineers and problem solving. Now, in our current education systems, we teaching math, physics, electronics, programming, science, many different subjects. And these are really tools to take us further in our career development. But the thing is, the students, young or university students, they coming out with a knowledge of these tools, but they don't really know how to apply them. They don't know how to glue it together. And for the most part, when people get into the industry as a freshman, they almost starting from scratch. They need to now learn how to use all of these tools and subjects that they learned in the universities or in schools, and actually apply it in a real world. And it really depends on how good the mentor that you find in that industry, in that new company that you're landing as your first job, first, second, and so on, as you progress in your career. So in this little bubble of how do we use different subjects, the education system today doesn't really help. Excuse me. So the reason that it's happening, that first of all, we need to understand that engineering system is talking to us. Engineering systems have a voice. And when any system fails, or there's a failure, there's a problem, there is an opportunity for us to grow and actually innovate. But we're approaching the humanity today, approaching these failures in two different ways. One is something called containment. And realistically, it's just fixing something that is broken, and it's going back to basics. For example, it's punctured tire. We just making sure that the air doesn't run out, so we glue the hole, and then we it kind of back to normal. Or the pipe is leaking, so we're fixing the pipe. The window is broken, we're fixing the window. But realistically speaking, it's not really helping us in any progress. We're just putting the system back to where it used to be before it broke, right? So we see that as a lost opportunity. The other approach is to actually solve the problem. An example with a window is, how do we make sure that window never breaks, right? How do we change the approach? How do we change the system in a way that it never breaks, or maybe there is no window because it's not needed anymore? This is where the innovation happens. And this is actually the gain opportunity where we can potentially even make money, create new products, create new processes, and so on. Unfortunately, today, a lot of companies and a lot of engineers, so-called, they actually trying to fix what's broken. And as we mentioning here, don't fix what's broken, try to innovate. Now, one note about the cost that this lack of innovation creates in the world. There's a lot of studies done on the market by different companies like Accenture, who said that basically 90% of new products fail in the world. Or PwC, they're saying over half of the companies, they struggle with innovation processes in their business strategies. And there's a lot of studies like similar to that. Bottom line, the cost of innovation as of 2019 is $1.4 trillion a year, and it's actually growing at the rate of 17.4%. So just imagine, what can we, if we fix that, what can we gain from it? So since we talked about the problem solving, let's dive into it. And we see problem solving as a science. It's not just trial and error. It is a science that can be and should be taught. Now, the origin of problem solving is actually coming from the patents. There's a lot of patents in the world being created by many different people that, they came across a a problem, they found a solution, documented it, and patents is really a documentation of a solution, a particular solution. Now, by studying all of these patents, and it's important to understand that studying all of them and systematization of all of the patents, we can actually learn how people thought when they came up with this particular solution. What was their thought process? What was their engineering thinking, right? Now, interesting fact to mention as well is, as you probably know, many examples in the history that different people in different parts of the world came across similar problem and came up with a similar solution. They provided a similar solution. So it's interesting. Why is that? And the reason for that any engineering systems, they evolve, their evolution is governed by objective law. And what that means is we don't really have a choice of how the system is going to develop. Like an example of an iPhone or any smartphone today, it's not, it looks like it does today, not because the designer was very smart or genius. No, because he didn't really have a choice. That's the only choice he had. Same with the computers, same with the car today, or anything, in fact, that is getting developed and evolve over time. So by learning these laws and understanding how to work with them, we can get better at problem solving and eventually innovate. Now, the objective laws, they have three major pillars, three major components, if you will. First of all engineering systems, they evolve with one target, to satisfy our client, to satisfy our customers' needs. The second is every system, any engineering system in the world, will be made out of multiple different parts or components. These components will always be different in how well they developed, how far they developed. You will have one component that is more developed and very innovative, very efficient and everything, and some other components that least innovative and least efficient. And of course, many times we investing in the least efficient to improve our products. And the third, not least important, the progress of engineering system is coming from the fact that we're resolving conflicts within a system. As an example, a car, we want to go faster with a car. Of course, easy enough to take and give it a little bit more power, but then we wasting more gas. And there's many of these examples. Now, when you solve that conflict, that contradiction, you actually start innovating. Do you want to add something here, Anatol?
No, great, excellent.
Great.
Thank you.
So let's move on. As any other thing in the world today, engineering thinking also have a set of tools that help us with that process. Now, if we're going by the example, we can say a hammer, right? Why do we need a hammer? We could, use a stone or use a hand, but hammer really gives us some additional abilities to do the work, like additional weight, hardness to our hand. Great. Another example is a car or truck in this case. It's an additional strength again to move weights faster and potentially bigger weights. Excel gives us more memory and ability to calculate faster and much bigger numbers, much bigger volumes of numbers, and so on. So engineering thinking tools, it's the same thing, but for our intellectual capacity to solve problems, innovate, generate more ideas, and so on. If you think about it, these tools, they give us somewhat superpowers in our engineering abilities. Let's dive into a couple of examples here in engineering thinking specifically. and how they will try to show how they different from a regular attempts or traditional attempts to solve problems. And the first example is as simple as defining the problem statement and really understanding what is the problem that we're trying to work on and trying to solve. And we love this example of a flat tire. And the question is, what is the problem here? And is the flat tire is a problem? The answer is no. The flat tire is a failure. Now, failure can potentially cause multiple problems. And in this case, we described just 4 examples, but it could be much more. You know, the fact that we have flat tire, we cannot drive, or we're late somewhere, or now we need to waste more money to fix it or to do something with it. Potentially, it's a life-threatening situation in the middle of a desert. There is no water, no food. Now we cannot drive, we can't progress. And that's just one example of a failure, and that's important to understand, causes multiple problems. And what we're solving, it's up to us. The easiest way to identify what is a failure and what is a problem is to ask ourselves, can it be fixed? Or because basically the rule is the failure cannot be fixed. Problem can be solved though. And an example for that, let's take the same tire. Let's say there's a puncture in a tire. We can glue that hole, yes, but the tire will never get back to the same condition, to the same new condition that it was before. It will still have a hole in it, but glued. So we can solve the problem of air running out of the tire, but will not ever fix the failure. Another example is, for example, a broken leg, right? Broken leg is a failure. And even when we treat the broken leg and the bones heal, it's still going to be broken and healed, but broken. So we're solving the problem of walking, but the leg or bone will never come back to exactly the same new condition as it used to be before. Okay. So to summarize what the problem is not what you see, hear, or feel. The problem is what you should do differently, potentially, as a result of what you see, hear, or feel, right? And back to the example of a tire, now I need to do something else. Now I need to waste more money, or I cannot do what I wanted to do, like driving, and so on. So defining the problem is one of the probably most important tools in problem solving and engineering thinking. Without that, we cannot really progress. Another example that we wanted to talk about is root cause analysis. A very popular tool, very well known. However, traditionally, root cause analysis or root cause as a definition is a fundamental reason for the problem, right? It's great to know what is the fundamental reason, but it's actually then it's not really helping us in any way. For example, fundamental reason that, you know, the earth is flat. There is nothing we can do about it. However, there's a practical definition, and we'll have an example in a moment, but there is a more practical definition that says a root cause, it is something that if we eliminate or fix, the problem is decreased or removed completely. That is something that we can actually act on, and that is very helpful. And let's go by example. Let's say we have a failure, and the failure is I have a headache. Great. Why is that happening? And yes, we're using again, one of the traditional tools of 5 whys. Why is it happening? Well, potentially I have a high blood pressure. Great. Why is that happening? Because high salt concentration in my blood. Why is that happening? I really love full Irish breakfast, having it every day. Why is that a problem? Well, I have stomach problems, so Irish breakfast is not really working for me. And why do I have stomach problems? Well, my mom actually smoked when she was pregnant with me. Now, This is technically the fundamental root cause, which is great, but it's not really helpful for me. This is what's called a dead end, something that we can affect the future mothers and make them not smoke in the future, and that will make the future generation better to have less headaches. But for me right now, it doesn't solve anything. However, if you look back, for example, at stomach problems, well, maybe I can do surgery and actually fix it this way. Well, I don't want to go to surgery. What about the Irish breakfast? Maybe I can, change my diet. Great. I don't want to change diet. I love my Irish breakfast too much. Well, let's go next, right? High salt concentration, maybe drink some more fluids, more water. I don't like that. I prefer something else. High blood pressure, there's also always medications for it. And then if I'm too lazy to even do that, I'll just take painkillers and solve the problem this way. So as you can see, instead of having one potential root cause that I cannot do anything with it, all of a sudden I have 5 different options for solution of my current problem. And this is what we refer to. The root cause is not the fundamental root cause, but is the one that you decided to address and solve your current problem.
Great.
Anything to add, Anatoly? Sorry.
No. Great. Very, very good. Very good. Very clear.
Okay, great. So let's get to the PRIZ Innovation Hub. So PRIZ Innovation Hub or PRIZ Innovation Platform or just PRIZ Guru, it had many different names and implementation over time. In reality, in short, it is a machine assisted facilitator for problem solving and innovation for innovation projects. And realistically, it's a collection of many different tools and processes that put together in one place as a tool to that help us to solve problems, to eventually innovate, to basically support our engineering thinking in our work life, and so on. Now, why is it important? I want to go back to this slide and look at this again. So we talked about math, right? There's some tools and software that exist. One of them is MATLAB. Great. What about electronics? There's a lot of CAD tools that are available out there for simulation and building the microelectronics layouts and so on. Same with physics. There's a lot of simulation tools that exist for physics. I'm not even talking about programming. Software engineering have enormous amount of tools out there. Now we determined that that missing piece is engineering thinking. Well, the tool for engineering thinking is PRIZ. And this is exactly what we provide. Now, a couple of samples in here. And before we dive into that, I want to mention that PRIZ is split into 2 major pieces. Is the platform itself, where the work is actually done and problem solved. It's the whole project execution management, collaboration, and so on. And then there is a hub. A hub is more of a public-facing, and we'll talk about this in a moment. It's more of a public-facing interface where you can make your work public and pretty much show off. So let's dive into that. In the platform, everything is organized as projects. So even small project could be 5 minutes project, could be 5 months project. It doesn't matter. It's still within the context of the project because we want to keep all the information related to that in one place. And everybody who is allowed to work with the same project, they work on the same information as a collaborative team. Of course, as we talked about the problem statement, we built a whole process of how to help people to build the problem statement and actually identify which problem to work on. Then we're diving into the heart of our system. And the heart of our system is actually creative thinking tools or problem-solving tools. And it's just a small example of what we have, just some screenshots. So we have some of the well-known, like cause and effect chain and 5 whys, but some least popular, but actually much more powerful tool that help us think on a problem, help us identify the better solution, better approaches, help us think as an engineer. Overall, currently we have 11 tools. Again, as I mentioned, 5 whys and cause and effect chain is something very well known, and brainstorming, for example. We added our own twist into all of them to make them more usable in a way that we think is better for engineering thinking. But some more advanced and least known tools like functional modeling and process functional modeling, this is where the real magic happens based on what we've seen from people who are working with these things. Now, a little bit a word about, you want to add something, Anatoly?
Yes, please. Let's add. We have 40 principles, tool, and we have a really new tool, action preventing action. This tool was created within our company. This tool helps to understand what our customer needs. I'm not sure you can find some relevant tool in the internet besides our tool.
Right. So again, since we're talking about trees, and by the way, hence the name PRIZ, trees is a theory of inventive problem solving. We replaced T with a P because it's a practice of inventive problem solving. And yes, all of these tools, apologies, some of them coming from trees, like in inventive principles or 9 windows, for example. Functional modeling is also partially coming from trees. And like some others, the action preventing action, it was actually invented by Anatoly and implemented in the platform. All of these tools, they, in one way or another, they working together, they contributing different, since the tools built with a different target in mind, they complementing each other as for different purposes. For example, round robin ranking, it's a tool that helps us to make a choice. And it's integrated into multiple different places in the platform where we have more than one option available and we need to make a decision. Mm-hmm. So let's talk about AI, for example. This is a big trending thing today. Of course, we couldn't do it without AI, and we embedded already partially, and we continue developing an AI-based facilitator, or in a way, companion. Now, AI in our mind is not something that can solve problems, and it probably never will. We still need a human being to solve the problem, or solve the problem inventively to create something new. AI bases itself on the existing information. It's trained by definition on the existing information. Hence, AI can find existing solutions out there or suggest existing solutions out there, but it can't invent anything new. What it can do, and this is how we envision it, it can be a companion or a co-worker, if you will, or an assistant to anything that you're working on, right? As you know, many times you need to have a conversation with somebody to just get your brain going. And this is what AI really helps with, right? Instead of starting from scratch, we're using the artificial intelligence to get you going, to start with something. And this is an example of where we using artificial intelligence to help us to build problem statement. This is an example from cause and effect chain. And again, we're developing these capabilities more and more as we go. As we talked about previously, a hub is where the work is publicized. You can envision it as a social media for problem-solving community. And if you think about it, you can think about it as an additional thing for your portfolio as an engineer that capable of solving problems. And now we have proof for that. That's a portfolio for problems solved by whoever is the engineer is. And these things that are accessible online, that are accessible publicly, almost it's an additional to your resume, if you will. Now, we talked about a lot of things. We talked about the tools. We talked about why is it happening, why the problem happens with how we solve problems today. We're dedicated to change that. And in our mind, the only thing to change that is to change the whole culture of creative thinking and how we solve problems. And the only way to do that really is by education. And the easiest for our own future is to educate our kids. So we have to prioritize education of our kids, education of, it doesn't matter, there is no limit to the age when you can learn, but I think for the kids, it's the most important to change the basis of how they think. And I think that's it.
That's it.
Thank you very much.
Great. Thank you.